Hello and welcome to another video. In this video we're going to be working on sort the jumbled numbers. And in this one you have a mapping of integers to other integers, and you want to sort a bunch of numbers by what they map to. And if they map to the same thing, then you want to preserve the original order. So the way the map works is you take every single digit of the number and you look at its mapping. And so whatever digit you are, you look at that index in the array and that's where you map. So 9 would look at index 9, which would be a 6, and so on. So in this example, 991 maps to, let's take a look here actually. So we have 991. So what you do is you take the index of each number and you map it to that. So 9 maps to 7, 9 maps to 7, and 1 maps to 9. Is this correct? Nope. Okay, it should be the other way. Okay, there we go. So it should be 669, I believe. Yep. Okay, and then you have 38, which maps to 0 and 7, so 0, 7, and 338, which maps to 0, 0, 7. So then you look, like, what's the order? So the 0, 7 should go before 669, so 38 and 338 should come first, but because they map to the same thing, you preserve the original order. So it goes 338, then 38, then 991. And the second example is similar. So basically, what you're trying to do in this problem essentially is, given a number, map it to another number, and then use that to sort somehow. So there's a few ways you can map to another number. The simplest one is just convert it to a string. So let's say you have 991. You just convert it to a string, and then go digit by digit, and then look what the conversion is, and that will make it easier. Another way, if you want to save space, is you can actually just keep track of what decimal place you're on and what the digit is. So if we have 991, we can just say, like, okay, our decimal place, we're going to always take the rightmost number. So our decimal place is the 1 decimal place. So it'll be like the ones place, the tens place, hundreds, and so on. So let's say we have some big number like this. So our decimal place starts at 1, and we're going to take the last digit, which is just the number modded by 10, and we're going to see where it is. So it should be a 6. And then we're going to multiply it by the decimal. So it would be 6 times 1. So we get 6 times 1. And then we'll keep adding all of these together. So we get 6 times 1, then our decimal place. Every time you go to a new number, your decimal place will 10x. And you can just divide by 10 to get rid of that. So 7 maps to 5 times 10. So that'll be 5 times 10. So I guess I'll just write it out as numbers. So it'll be 6 plus 50 plus, we get rid of this guy now, and we multiply this by 10. So we get 100. So this is 8 maps to 7, so 700. And basically this ends up being 756, right? So basically you're just going to keep adding like an integer in front every time. So now this is 1,000 divided by 8. 3 maps to 0, so that's just 0. So actually we do want to write it. Yeah, we do want to write the 0. So yeah, so that'll be 0 like this, and then multiply by 10 again. Technically it doesn't really matter, like the 0 won't matter, I guess, so we don't have to write it because this will be this. Then we get rid of the last number, and then this is 2, so 2 times this guy, so that will give you 20, and then 3 zeros, so like this. Then we get rid of the last number, and we multiply by 10 again. So this is like one way to do it. And basically what this will do is this will give you the right digit in the right spot every time. So this is 5 and then 5 zeros, so 5 just over here. So this is your answer. So that's how you convert from like one number to the other, and then you just have to make sure, we're going to do this until our number is 0, so you just have to make sure if your original number is 0, then you return whatever 0 maps. So you just have to check for that. But let's say you have like the number and the number it maps to, then what do you do? So this is kind of the same thing that I was saying yesterday. So we need to sort on two things. We need to sort on the map and then its index, right? Because if there's a tie, we want the one that comes first to stay first. So what we can do is we can store the number, the index, and the mapping. And then we can sort based on those conditions. So we can say, like, let's sort on the mapping. And if there's a tie, then we can sort on the index. And it's just a custom sort, just like the problem yesterday. And in Java, because the mapping, I guess technically, actually, this is technically integer. You can store it as like length 3 arrays, but originally I think I had this as like integer string because I was doing it as a string. Then you can't do that. But what you can do in Java, if these are different types, let's say, is you can just make another class called like tuple or pair or whatever, and then that class can have 3 values, and then you can use that. And I'll kind of show you that. In another language, you can just use the normal array, because in most languages that aren't static, you can have something like A1, whatever. But in Java, you can't. So yeah, I guess I could have converted this to like length 3 arrays instead of tuples, but I'll show you how a tuple would work as well. So you can make these like tuples, and each tuple is going to have the number, the index, and whatever it maps to. And then you can make a class that would just things that it has called tuple. So you have the original number, the index, and the map number. And then you can use those, and then that way you can basically have like arrays that have different types together. In this case, they're all integers, but if you had like integer double string or something, you can do this kind of thing. Anyway, now you can make a custom sort. So you can make a custom sort on anything but a primitive int array. So because this is like an object, you can do that. So we're going to sort, and our condition is going to be if the map nums are the same, we're going to sort by index, and we want it increasing. So I think I said yesterday, if you want it increasing, you do a minus b. And if the map nums are different, then you just do the map num minus the other map num. So this will sort based on the map num, this will sort based on the index, and if you want them both increasing, you do a minus b for both of them. Then we just get our result, and we get the value we want. So we want just our original number, and then we just return that. So this could be refactored to, instead of using this, or actually, you do need this, but instead of using a tuple, you could use arrays of length 3. So it'd be like a nested array where you have an array of length 3. And here's the map number function. Oh, this is screwed up. Let's see. Like this, I guess. Okay. So basically, like I said, if it's 0, we're going to want to return the mapping there. And otherwise, we just keep track of the tens place and the total result. And we just say, while the number is non-zero, let's keep getting its last digit, multiply by whatever tens place it is, and add to the result. And multiply it by whatever that digit maps to. Then divide by 10 and multiply the tens place by 10. Then we get our number back. Yeah. And it's pretty good. So yeah, you can use a tuple, can use array length 3, depending on what your use case is. Like I said, I had a string originally, that's why I have a tuple. So this is time and log n, because it's a sort, space. So what are we doing here, I guess? We're creating a tuple for everything, so that's just linear. And then basically, how long does it take to map a number to another number? So because a number can only be 10 to the 9th, you're going digit by digit, and that will take you the number of digits in the number. So this is basically like O of 9, which is constant time. So you can say the mapping is basically constant time, and then the sorting is n log n. And as far as like the space we have, so we make this tuple pairs thing, which is linear. Yes, I think it's just linear. Yeah. I guess this is going to use my what I wrote, which is kind of silly, but yeah. Yeah, and definitely these kinds of things are a lot easier in Python, a lot less. It's a lot more convenient for these sorted things. So I'd say the upside of Java for these things is Java has a lot more built-in functions you can use, I feel like, and a lot more data structures, but it is more verbose. So, and I do think, I also post these things in TypeScript. I think that one's probably the worst to use for most of these. It's actually pretty good for this problem, but in general, for these kinds of LeetCode things, I think it's the worst. And yeah, I think that's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.